before we get started, all right, guys, focus in. Before we get started, are there any questions on the homework assignment?
Actually. Can you show me the homework page? No. Actually, I already did the page on my own. Yeah, I don't want to do that.
The cube root of 8 is 2, because 2 times 2 is 4 times 2 is 8. And now when we take this cube root of 12x, well, that's the same as e to the 12x over the index. 12 divided by 3 is powers of powers, because really we could say it's the same as 4 cubed times e to the negative 2x times 3. Powers of powers multiply, because we can say 4 to the first, 1 times 3 is 3. 4 to the third is 64. Negative 2x times 3 is negative 6x.
Yeah, you did that too fast.
So powers of powers multiply. 2x times 3. Negative 2 times 3. Yep. 4 to the third. We can just do that in the calculator. That's it.
Thank you.
You're welcome. Yes. Yeah. Pass these out in a minute. What we're looking at today is logarithms. Logarithms and exponentials are inverses of each other. We can change it from a logarithmic to an exponential. Now, log base b of y equals x if and only if b to the x is equal to y. So log base b of x equals y if and only if b to the y is equal to x. So if we look at this here, log base 2 of 16 equals 4 is true if and only if. So our log base b of y, or x, equals y if and only if b to the y is equal to x. So if we look at the first one, log base 2 of 16 equals 4. So what took the place of b? 2. So what we're wanting to do is rewrite it in exponential form. So we're wanting to go from here to here. So b to the y, well, we have the b value is 2. What took the place of our y? What's taking the place of y? So we're saying 2 to the 4th is equal to x. So 2 to the 4th is equal to, that's it. So we changed it from logarithmic to exponential. Yep. Now the nice thing about exponential form is we can check this. 2 to the 4th power is, so is 2 to the 4th equal to 16? Yes, that is a true statement, so we did have it right. Let's look at the next one. Log base 4 of 1 equals 0. So again, we're wanting to go from logarithmic to exponential. So our b to the y is equal to x. So for the next one here, what is our b value? 4. What is y? Equals 1. So we're saying that 4 to the 0 is equal to 1. Yeah. Questions on these here? Log base 12 of 12 equals 1. So how would we rewrite this as an exponential? 12 to the first. 12 to the first is equal to 12. and that's it. Let's look at the next one. Log base 1/4 of 4 equals -1. So 1/4 to the -1 is equal to 4. 1/4 to the -1 is equal to 4. Questions on these here? Log base 6 of 216 equals 3. So 6 to the third is equal to 216. B, log base 7 of 1 equals 0 would be 7 to the 0 equals 1. Log base 21 of 21 equals 1. 21 to the first power is equal to 21. Log base 1/5 of 5 equals -1. 1/5 to the -1 is equal to 5. Questions on these here? Okay, we ready for the next one? Rewrite each logarithmic equation into, or each exponential equation in the logarithmic form. So b to the y is equal to x if and only if log base b of x, it's supposed to be b, log base b of x is equal to y. So far we've gone from logarithmic to exponential. Now we're going to go backwards. We're going to go from exponential to logarithmic. So log base 5 of 25 equals 2. So our base is 5, our y is 2, the x is 5, or 25. Let's look at the next one. 10 to the -1 is equal to 0.1. Log base 10 of 0.1. Yes. Questions on this here? Are you ready for the next one? Eight to the 2/3 is equal to 4. Log base 8 of 4 equals log base 6 of So it is interesting that when the exponent is negative, the number that we get is a fraction. Because again, to make the exponent positive, we'd have to move it from the top of the fraction to the bottom. So it's really looking at 1 over 6 to the third, which would give us 1 over 216. All right, 4 more. Let's look at them. 9 squared equals 81. Log base 9 of 81 is equal to 2. 20 to the -1st is equal to log base 20. Yes. Next one is of 8 equals. Last one. 15. 5. One of the things I will say, just make sure that the base is a little bit smaller and down so we do know that it's a base. Yeah. because it is very, I do see it every so often, and I'll get something like log base 20, like this here. Again, it is something different. We need to make sure the base does look like a base, not just a number being multiplied. Because we will get to it, there is something called the common log. If the base is not written, it's understood to be 10. So if it does have a base, we need to make sure it looks like it is a base. Evaluating logarithms. Now there's two that are very good to know. Log base b of 1 is 0. Log base b of 1 is 0. Because if we rewrote it as an exponential, we're saying that b to the 0 power is 1. So if 1 is inside that logarithm, we know it's going to have to equal 0. Well, as long as b is not equal to 0, we can't take log base 0. This does not work. Also, if the base and the number inside the logarithm are the same, it's going to equal 1. Because if we rewrote log base b of b equals 1 as an exponential, it's just b to the first is equal to b. So these are just some that are good to know. So log base 4 of 64. We're wanting to evaluate this. So let's rewrite it. So we're going to say equals what? Well, we don't know yet. So we can say equals x. That's all variables are. They're just representing an unknown. And if we solve this here as an exponential, how would we rewrite log base 4 of 64 equals x? 4 to the equals 64. So really at this point we're saying what power do we have to put 4 to get 64? Mm-hmm. 4 to the 6th. 4. So log base 4 of 64 is 3. So we're saying 4 to what power? It's 64. So 4 to the third power would give us 64. Let's look at the next one. Log base 5 of 0.2. We want to see what this is. So if we did the same thing, we wrote it as an exponential, we'd be saying what? 5 to what power is 0.2? So positive numbers gave us a bigger one, yes? And if we notice on some of the previous ones, when the exponent was what? Negative, the number got smaller. So what number could we try putting 5 to? So let's try negative 1. Is 1/5 or 0.2. So x would be negative 1. Now the next one would be 1/5 to the x equals 125. If y'all were to guess, what do you think this would be? Well, let's say 5 to what power is 125? We'll take a guess. Because we got a calculator here. 5 to what power? 3. Is 125. But we're not asking about 5. We're asking about 1/5, yes? 1/5 to the third is, let's try negative 3. because a negative exponent is going to make a whole number smaller. It's going to make a fraction bigger. And part of the reason for this, because if we applied this, when we have a negative exponent, to make it positive, we've got to take it from the numerator to the denominator. Essentially, we flip it. So with 1/5, to make it positive, we have to make it 5/1, which will get us our value. And the last one, log base 36 of 6. So you can say 36 to the negative what?
Can we use it like fraction?
Mm-hmm.
I was thinking, I literally, yeah, that's what I was thinking.
Square root of 36 is 6. As we went over yesterday, 1/2 is the same as our radical. Questions on this here? All right. Log base 4 of 256. Quick. So, math. So on the 30XS, or on the 84, our graphing calculators, if we hit math and scroll up or down, there is a function called log base. So we have this here. Now the one we're looking at, log base 4 of 256. So we can put 4, we can put the 256, tell us that it is 4. Math, log base 8 of, what is it, point, math, log base 1/3, 1 divided by 3, of is
JB's got a question. I got some.
yes. Log base 4 of is 1/2. Questions on this here? Questions on anything we've done so far? Next one we have is natural logs. The natural log of x equals y if and only if e to the y is equal to x. Natural log, it's understood that the base is e. We don't write it, but it's understood to be e. So with natural logs, we have an understood e as the base. Common logs, so log, if the base is not written, is understood to be 10. So, let's look at this here. ln of 6 equals x. If we rewrote this as an exponential, we would have what? So the base would be e to the what? Because even though we have natural log instead of log, the way that we go from exponential or go to exponential isn't any different. So the natural log of 5a, the 5a is connected, equals b. So what's our base again? E to the b is equal to 5a. Now we can't use definite examples for this here because e is irrational, so it actually would be approximate. We can't have exact values. So the next one, the natural log of 42 equals b. How would we rewrite this as an exponential? E to the b equals 42. Natural log of z equals 6. So this e to the 6 is equal to z. Are you ready for the next one? The natural log of 4 to the y is equal to d. So e to the d is equal to 4 to the y. The natural log of 3 to the a is equal to e. So this would be what? E. E to the e is equal to 3 to the a. Because we can have e to the e. We ready for the next one? Now we're going back to natural logs. So we're going to go back to our logarithms. So what would we have? The natural log of? Because the base is e. We don't have to write it. But natural log base e of what? Not x. Equals 2x. So really all we have to write, we don't have to write that base at the e because it's understood. So really all we'd have to write for this here is the natural log of y equals 2x. Let's look at the next one. E to the 57 equals z. Natural log of z. The natural log of z equals 57. Because the base e is understood, so we don't have to write it. Same with the base 10, log base 10. Questions on these here? It is a little different because the e, the base isn't written, but it's understood. E to the 9y equals 6. So this would be the natural log of equals 9y. E to the b equals 4. The natural log of 4 equals b. All right. We're going to evaluate using the calculator. So log of 8. Now this is a common log. Log of 8 is a common log because it doesn't have the base written. Now with common logs, we can do it in either calculators. Because the log button, LOG, we can just hit it. We don't have to do log base because the base is understood to be 10. So log of 8 is 0.903089987. See what it told us to go to? 3 decimal places. So 0.903. part B wants the natural log of 0.3. Natural log of 0.3 is negative 1.203972804. So 3 decimal places would be negative 1.204. Since the number after the 3 was bigger than 5, we round up. Questions on these here? Log of 98. Log 98 is 1.9912, so 1.991. Let's see what log of 9.8 is. 0.1992 or 0.991. Questions on this here? Let's see here. Let's see what log of 980 is. 2.991. Natural log of 7.84. ln 7.84 is 2.059. And even the natural log of 79 over 2. .676. Questions on this here? That's it.